On this episode of This Week in Space, planetary scientist Jim Bell joins us to talk Mars sample return, Viper, and why we must better prepare for people to go to the Moon and Mars. Join us.
Podcasts you love.
From people you trust.
This is Twit.
This is This Week in Space, episode number 130, recorded on September 27th, 2024. Dogs on Mars, snakes on the moon. Hello and welcome to another episode of This Week in Space, episode number 130. We have come up upon, yes, we're hitting bigger numbers, that we like to call Dogs on Mars, Snakes on the Moon edition. And yes, that's a bit of clickbait for me. I'm trying to, I'm setting, Tarek has set the bar high. So I'm trying.
I do
trying
not
to beat
clickbait.
You. No,
I don't understand.
Not.
I didn't understand the title when we first.
Well, it's referring to Viper on the moon and the Mars rovers dog. Get it? Yeah.
Oh yeah, now I.
Now see, pretty clever.
Wow.
So I, of course, I'm sorry to tell you, I'm Rod Pyle, editor-in-chief Badass Magazine, and I'm joined, and it warms my heart to say, as always, by the eclectic Tarek Malik, editor-in-chief of the Rosetta Zone of Space. Space.com. How are you, sir?
Right. I'm doing well. How are you, Rod? How are you doing?
I'm okay. You know, I could probably come up with some complaints, but who would possibly care?
It's a nice gray day here on the East Coast. I like gray days. So
you're a strange person, but okay. But soon,
so quiet.
to make things incredibly normal again, we'll be visited by Dr. Jim Bell, who's a planetary scientist and professor at Arizona State University, and an indispensable member of NASA's Mars rover teams, among other missions, to discuss the potential end of Mars sample return, maybe the same for the Viper rover mission to the moon, and why both these are critical to human exploration in these places, and some other topics. But before we start, please don't forget to do us a solid. Make sure to like, subscribe, and do all the other things that support podcasts, because we want to keep bringing you this stuff, and we need to show the world that you care. So give us a thumbs up or whatever the appropriate measure of value is. And now, a space joke from Martin Harris.
Martin.
Hey, Tarek.
Yes, Rod.
What prize did Orion get when he came in last in the race?
I don't know what kind of prize did he get?
A constellation prize.
Oh, I thought you were gonna go like belt right for that, like some kind of like a belt because of his stars. But no, that's good. That's good. I like it.
Well, you'll see stars once I built you.
Now, it's a bonus. Yeah, I think you did that, everybody. So.
Believe me, you can tell. I've heard that some folks want to send us to Mars to suffer a horrible airless death when it's joke time on this show. But it doesn't have to be that way. You can help save us from the cancellation of our own joke mission. Send your best, worst, or most indifferent space joke to us at twis@twit.tv, and we'll use it. And we'll give you credit and everything. And I'm going to turn off that phone call that I just got. So let's do some headlines. We're a little tight on time this week.
Headline news.
I like it.
Isn't that snappy?
Yeah.
We finally
I feel so modern.
Yeah, well, that wouldn't fit me. So I'm just going to toss these to you because it'll save us some time. So Crew 9. The rescue mission.
Not to be confused with K9, the robot dog from Doctor Who. Crew 9. SpaceX is launching 2 astronauts to the International Space Station this week. Kind of a weird month for them because initially this mission was supposed to launch 4 astronauts to the International Space Station. Now it's only launching 2. NASA astronaut Nick Hague and Russian cosmonaut Alexander, I think I'm going to get this right, Gorbanov, are launching. And then they're going to have, I guess, extra supplies and stuff in the other space, because this is now kind of a delivery / rescue mission for...
it's a bring them home mission.
Bring them home. Well,
we're not calling it a rescue mission.
We're not going to call it a rescue mission. I guarantee you're going to see our launches rescue mission headline.
Oh, yeah.
From somebody, not from
space.com.
space.com.
Many.
We might mention the Boeing Starliner astronauts in the headline. I don't know, but we're probably not going to call it a rescue mission. But this is the mission that will launch. That will launch 2 people up and bring 4 people back, so that Butch Wilmore and Sonny Williams, who launched on Starliner and then stayed behind as their spacecraft came back to Earth, will be able to come back after 8 months. 8 months after their 8-day mission launched, they will come back to Earth.
How about mission salvage?
Yeah, I guess that, I could see that. The sad part is that the 2 slots that were set aside that are now not going to be flying are rookie astronaut Xena Cardman. She was actually going to command I think the flight originally, and 3-time space shuttle flyer Stephanie Wilson, and that's kind of a little disappointment. I'm sure very disappointing to her, because she's a very veteran senior astronaut. And this could have been the last flight for her. Maybe they'll replace him. It seems like in the past, at least in the Apollo era, people got bumped. They would get to fly again. I hope they get that chance in the future. But at least this mission's getting off the ground, delayed a few days because of Hurricane Helene, which delayed it from the 26th to the 28th. Now it's going to launch at 1:17 p.m. Saturday, 28th. So you can watch it on space.com. And
1:17 p.m. East time?
1:17 p.m. Eastern time.
Because remember, we do have other time zones.
Oh, yeah. Well,
I know you guys don't think so.
There's other time zones than New York City? What? No.
Yeah, that's GMT, maybe, where it was invented.
15:17 GMT.
There we go.
11:17 in California there for you, Rod. So I did some math. That's good.
Okay, and we have a new space plane to talk about.
Yeah, this was interesting. This one came from Space News. Space News reported that this company, Seattle-based company Radian Aerospace, has plans to build a new reusable orbital space plane. And from what I was reading on their description, this company, they're ambitiously looking at single stage to orbit, which who is looking at single stage to orbit anymore? It's so exciting. But they unveiled like their scale prototype of the vehicle. It'll have a 15-meter, I believe, payload bay that's about the size of a school bus or so, and this scale one is doing taxi and hop tests, so it's not flying yet. And it'll be interesting, because the idea for this single stage to orbit vehicle isn't like to take off on the runway and then rocket up. They're going to put it on a 2-mile long sled, is what they say, on a runway.
When worlds collide.
Right.
How cool.
Right. It's going to shoot it, slingshot it down, and then it goes up, and then it takes off. It's going to be really cool. I hope that it gets off the ground. The world could use more space planes, especially reusable space planes.
So wait a minute, though. So this is a rocket-powered sled that it takes it up and then falls off the end of the track as the thing continues?
I actually didn't get so far to see how they were going to power the sled itself. Like, I didn't see rockets on the design of it, so maybe they've got some other issue. That seems like a big technical hurdle that they're not thinking about right now. That's just the concept design.
Hey, Eugen Sanger was thinking of it in the 1930s in Germany before he decided to use it to try and bomb New York from an orbital skip bomber. So it's been thought of, but I'm getting carried away.
They unveiled this in Abu Dhabi, so in the UAE. Yeah. So clearly, there's like the testing is going on over there for the Seattle company. So very interesting, very interesting.
Was there? Oh, we have video.
So this video looks like it. Yeah, it does.
Yeah, it is rocket part of it.
Yeah,
that is cool. The only thing that it doesn't have is the track going up like it did in the movies, but that would be a big build. Well, that's a pretty cool looking space plane. I think
it'll be nice. And this one, in terms of like commercial space planes, seems a little bit more down to earth than. Do you remember that Skylon space plane that was like this?
It was Skylon and Hotal, which looked like a whale with a fin on its head.
Yeah,
that was British.
So so we'll see though. We'll see.
So many planned space planes, and the only one that ever flew successfully for any length of time with people on it was the American shuttle. Buran flew uncrewed a couple of times to the Soviet Union.
I think one time, and then it bent the airframe, and then that was it, right?
Oh, was it just once? Yeah, you're right.
It launched into space one time, but I think
there were approach and landing tests before that or something.
And it's gone. It's gone forever.
Yeah. Gone. Well, and it's gone. I mean, one of the fuselages got the shed crashed on it because they weren't taking care of it. All right. And finally,
yes,
your third story, please.
My third story is about
Moonlet.
the new moon that Earth will get this weekend. And this is very exciting. You might have all heard about this, and I think we've talked about it at least once before on the show, but there is a new second moon of Earth that we're going to get. We don't get it to keep. It's like a lender's library of moons, apparently. But a small asteroid is going to get captured by Earth's gravity temporarily on Sunday, September 29th, as we're recording it. It's the asteroid 2024 PTS, which is probably how everyone is feeling at the end of this episode. But no, it's this asteroid, and it's going to be captured in Earth's orbit at 3:54 Eastern time on Sunday, and then it's going to hang around until about Thanksgiving, November 25th. And then it escapes our gravity, goes off on its merry way. Hopefully it doesn't come back and smack us. It's very small. But it's really exciting. You know, this gives scientists a chance to see a near-Earth asteroid up close for a little while. They look at it with telescopes, with those radar things that they do when they ping them to see how they look like peanuts, because they always look like peanuts. And it's a brand new asteroid, as its name suggests, 2024 PTS. It's the year it was discovered. So it was discovered this year.
So
and
I was going to watch the orbital plot on space.com, as we are seeing now for those of you watching video, but I think I fell asleep and aged another 2 years while I was waiting to see what the orbit actually became. So this is a great big, I assume very weak elliptical orbit that it will be in briefly and then depart, right?
Yeah, you know, it's
essentially an orbiting flyby kind of thing almost.
It is. It's what's called an I think I'm going to pronounce this correctly, Arjuna or Arjuna asteroid. There's an Arjuna asteroid belt, which is a secondary asteroid belt in our solar system made up of objects that follow orbits that are very, very similar to Earth, so at about 93 million miles away. So, you know, we're all kind of like, let's say we're all on the same highway as we're going in a circle around, you know, or an ellipse, pardon me, around the sun. And every now and then they by changing lanes, we end up like in the same lane. That's kind of what this seems to be to me. And some of them can get real close, 2.8 million miles or so, you know, going about 2,200 miles an hour. Asteroid 2024 it's not going to do a full orbit around Earth, even though it's going to be here for a couple of months. It's just going to be hanging around a bit and then be on its merry way. So
okay, so it really is a flyby.
Yeah.
All right, well, that's very cool. But what's even cooler is we're about to spend some time talking to Jim Bell. So stand by for this brief break, and we'll be right back. And we are back with Jim Bell, who's a professor, award-winning author, keynote speaker, and the list goes on and on from there. So, Jim, I'm going to do you a solid and ask you to tell us about yourself, because you have a long and winning resume. I often have gotten, it's been mentioned to me in the past, mostly by people from the East Coast, how come you have so many hyphens and slashes in your resume? And my usual answer is because I worked in Hollywood, but the truth is it's because I had ADHD. What's your excuse?
That's a great lead in.
How about that?
Thanks,
huh?
Rod.
Surprise.
Thanks. I appreciate Rod, Tarek. I appreciate you guys having me on the show. So yes, I'm a professor at Arizona State University. I'm a planetary scientist. I'm trained in geology and astronomy and study planetary surfaces of planets, moons, asteroids, comets, anything solid surface in the solar system. I'm interested. And I've had I started out in the telescope world, because back when I was a graduate student, there weren't all these NASA missions going on. We didn't have rovers on Mars and all that kind of stuff. So telescopes were still the way to go. And I've been fortunate enough to be able to take those skills with telescope instruments and apply them to spacecraft, rovers and orbiters and landers and stuff like that. So that's my day job. Also work very heavily with Planetary Society. I was president of the Planetary Society for a dozen years. I'm still on the board. Work a lot on our advocacy and education, and really trying to promote planetary and space science broadly across the world. That's kind of fun and cool. And you know, I write books, mostly picture books of late, but just trying to share the visual joy of space exploration in astronomy and planetary science with the public. So, yeah, I guess I don't sleep much. Maybe that's the answer. Yeah.
Well, if you're managing to get picture books commissioned in this publishing environment, my hat's off to you, because the last few times that came up, I think the last one I did was 2019, and we revisited the subject in 22 or 23, and the publishers were like, no, never again.
Right.
We can't afford ink.
It did take a long time to break in, and I talked to a lot of would-be authors, and I just say persevere, try hard, keep going, approach many, many different companies. And the key in my experience, the key is finding an editor who's a space nerd like we are, and they get excited about your project. And because of course they have to pitch it in the company and all that kind of stuff. So, but keep trying. Don't give up.
Although it's interesting, as an aside, I'll just mention, I did a book called Space 2.0 in 2019. First edition did okay. And, because it was a current thing, not a history thing, primarily, it was time for a second edition a year or two ago. And I talked to the publisher, a company called Ben Bella, who's a really wonderful company to work with. So the book has been selling for $20 for a number of years. It's got color plates, and it's all chrome coat stock and all that. They came back and said with the price increases since COVID, it would now have to retail for $50.
Oh,
because of ink, paper, and transport. And I thought, well, that's the end of that. All right. But more interestingly, I noted that you went from beautiful Caltech, which I used to live about 3 blocks away from, to Hawaii for your grad school. That strikes me as being a little hedonistic. You want to explain that?
Well,
or smart,
cool.
smart.
Maybe smart.
I mean, it was mostly because of the amazing telescopes at Mauna Kea, right? And University of Hawaii has access to those facilities. Students at the University of Hawaii have preference on some of those facilities if they're doing their thesis work. So yes, I went to Hawaii, but I was the only guy on the plane with a snow parka, boots, and gloves because I was working at 14,000 feet, and even in August we had blizzards, because you're basically in the lower stratosphere. So but great experience, great university for geology as well. I actually majored in geology there, but I was doing my geology through the tools of astronomy available to University of Hawaii astronomers. So.
Well, Tim, you and I first came, I think, met you. We were talking about, I'm sure it was some Mars like discovery or rover mission, and I'm sure we're going to get to that in a bit. But I kind of want to go at this point, kind of way back, to ask if there was a moment with young Jim Bell where, like, the space bug bit you, and that's what sets you on this planetary science path, or was it something which has happened that people find later in life that they were doing something altogether different, and then that something tips the scales and they discover a new passion?
Yeah, man, that's a great question. I guess 2 moments for me, one very young and one sort of teenager. The very young thing that I remember watching on TV, watching these guys drive a car around on the moon. And it's like, OMG. I want to do that. Look at that. These guys are driving a car on the moon. And it's on TV. It's like amazing. This is, Apollo 15, 16, 17, when they're driving around and kicking up rooster tails, and just, it was incredible. Just the fact that, there are people walking around on the moon and big rockets. And just as a little kid, just super exciting. And, of course, it was big national news and all that kind of stuff. So there was that. And but then as a teenager, it was great to, nerd out and learn math and all that kind of stuff, physics. But I didn't realize that people could make a career out of this without being an astronaut, really, until Cosmos. Sagan's Cosmos series, which, if you guys will recall, and people will have a hard time dealing with this, but remember, the world was 3 networks and PBS, right?
That's right.
And there was almost no science on television. And on PBS, there was Nova, still around, right? It was a spectacular show. And Nova would be space, 1 time out of 5, right? And so it was just so rare to have a space show. And then Sagan comes on, and it's like for 13 weeks or however long it was, every Monday night or whatever it was, it's like, here's an hour of this guy with a funny Brooklyn accent, and the tweed jacket, and he's talking science, he's talking astronomy, he's talking space, he's talking planetary science in English, in a language that I can understand, my mom could understand, and this was like, holy cow, this was just eye-opening. Of course, at the time, the special effects were great. The graphics that were coming out of that show were cutting edge, and all of the pictures of the Voyager and Viking and Mariner, all the classic missions of the 60s and 70s were featured because he was personally involved. And it was a seminal moment in my early life and ultimately career. And it's been so many people in sort of my generation, I'm in my 50s, my generation were so influenced by that show and the accessibility of it. The realization is that, you can do this for a living, and it's okay to communicate with the public and want to share your excitement and passion with the public. And of course, Sagan was vilified for that by his professional colleagues at the time. But now it's just a part of the field now. It's expected.
For the uninitiated folks who may not know who the Sagan is and what the cosmos is, we're talking about, of course, Carl Sagan and his show Cosmos: A Personal Voyage. It was 13-part series that was on PBS in 1980 to 1981. I watched that show. I felt like he was talking to me,
yes,
like, not to like everyone, but like to me, about like what was out there, and it was brand new as like a feeling. I mean, I was also kind of quite small when that show was out, but I watched it.
1980.
Yeah. Well, but I watched it was in reruns too, like on they would show it on PBS over and over again. So it's very interesting, just the path.
And then I had just an amazing thrill to be able to fanboy overlap with him when I started my career at Cornell.
Oh, that's awesome!
As a postdoc initially at Cornell, and that was just what a treat.
So did you meet Pascal Lee back then?
Oh yes, no, I know Pascal very well. We go back to grad school days.
Okay,
his grad school days. Yeah, my postdoc days, and
Because I didn't realize till he told me about a year ago that he was Sagan's last TA, and I thought, wow, what a distinction.
Yeah.
All right, let's jump to a quick break, and we'll be right back to talk more space. Stand by.
Space.
So let's talk Mars for a few minutes, if we can. Did you came in during the Mars exploration rover missions or Pathfinder?
Pathfinder.
So you were part of the Pathfinder team.
Yep.
Now, so I've known Rob.
Today's the anniversary of the last signal from Pathfinder in 1997. As we're recording this, so.
I've known Rob Manning for about 10 years, and I've told him more than once, being a bit of a fanboy, that watching those videos of his team and all of you collectively working on Pathfinder, and besides the fact that we were all younger then, but the enthusiasm and the joy you guys had for something that was pretty low budget, fast, kind of a Mars robot direct, if you will. I mean, that must have been a really incredible time.
It was spectacular, right? Because there was no such thing as better, faster, cheaper, right? Pathfinder and the NEAR mission to the asteroid Eros, which were both happening right around the same time in the mid to late 90s, were intended as the first demonstration that NASA, as this big bureaucratic government agency that does billion-dollar flagship missions, can do it a different way, can do it for a fraction of the cost, 10%, 20% of the cost of a typical previous mission, a fraction of the development time, and a bunch of generally early career people who were more willing to take risks to push the frontier of Mars exploration, and planetary science in general. So yes, it was thrilling. And, I was a relatively junior science team member, worked with Peter Smith and his team on the cameras for the lander. And so that was very exciting, cutting edge technology, CCD technology at the time was still pretty novel. And of course, being able to work real time on Mars time for nearly 3 months was both exciting and physiologically exhausting. But like you said, Rod, we were all young, so it was worth it.
We should remind people that Pathfinder in 1997 was the first rover ever that we landed on Mars with the Sojourner rover, and that had a ground station as well. And you got all these awesome photos. First time ever done. In fact, in Sacramento, they set off fireworks in the daytime for the landing on July 4th.
Yes, it was at the time the largest event in this new thing called the internet.
Right.
It was the largest public event that had ever happened, and it was great to be able to share that kind of stuff in real time. Because of course, when for like Voyager and Viking, you'd get little snippets of things in the evening news, right? It was no way to follow that stuff live and to see the fact that it's people who are doing this, and that people have so much invested in it, and that's why there's so much joy when it actually works, and so much despair when it doesn't. And I've been involved on the other side in a couple of missions that didn't work, and I assure you, the joy is much more worth it.
That's pretty amazing. And if I recall correctly, and correct me if I'm wrong, it was also the first and last time that the geologists were able to name features on the surface of Mars after what the NASA General Counsel later realized were copyrighted icons.
Like Yogi Bear!
Came back and said, don't do that. Name them after geological features in Canada. We'd much prefer that, or something of that nature.
Yeah, like, we were making it up as we went along, and
yeah,
we did have themes and all that. But yeah, it's, you get a bunch of tired people and you get kind of a little loopy. But it's all in good fun.
Well,
Tark, go ahead.
Well, I was going to ask, because you mentioned that was like the first of its kind, but we've seen a lot of rovers since then. I think I did a count today because it was our quiz in our newsletter that we've sent as a species 6 rovers to Mars, if my count is right. Someone,
correct.
Please. Yeah.
Yep.
So that's and of course I know that there's a lot of other planetary science that you've done there, but we had the Mars exploration rovers with Spirit and Opportunity, and then you mentioned one in your Persevere pep talk, but Perseverance, of course, and Curiosity are there now. But I think Rod and I did want to ask about just the general science that Mars and other things do promise in the I guess the years to come. Like there's you mentioned some science that we lost, like the Viper rover as well, and then the science that we want, like Mars, like sample return and whatnot too. And I'm just kind of curious, looking back, because this is kind of an anniversary. We did our On This Day in Space today. That's how I know about the Pathfinder anniversary.
Got it.
I'm curious if you had hoped that the progress of planetary science from that kind of on the ground exploration would have been farther than it is now, or is it at the pace that you expected, or did it even advance? I mean, you got nuclear cars on Mars now, faster than you could have thought when you were working on those earlier missions there.
Yeah, that's a great question. I think everybody you ask would have a different answer to that question, but I'll share mine. I think that the pace has been great for robotic exploration of Mars and other planets, the entire solar system, the universe. Let's not stop there, right? I think the pace has been great, partly because of the change in philosophy and the idea of backed by decadal surveys, by surveying the community, National Academy of Sciences every decade on how should NASA advance the exploration of space, and keeping this balance between the giant missions that cost billions of dollars, the Voyagers, the Vikings, the Cassinis, the Galileos, and having other categories of sort of medium class missions and then smaller missions and then really tiny missions that use up much less of the budget wedge, and the budget wedge is finite, and ultimately everything that we do with NASA is funded by all of us as taxpayers and all of you out there in the audience as taxpayers. And so that budget wedge, that's what we live or die by. And we're very fortunate in that the American people support NASA at a level greater than all of the other people in the world combined support their space agencies for civilian space. And so we're very lucky with that, but it is a finite box. And if you're just going to do big missions, you can only do so many of them. But the failure of Mars Observer, the last big giant Mars flagship of the sort of 70s and 80s era, that failure really sent a harsh message to NASA that the then administrator Dan Golden turned into this better, faster, cheaper idea. So let's break that science up into smaller missions. Let's have more opportunities. Let's try to launch to Mars every 2 years when the planets line up right. And that has just turned into this series of very successful missions that you've mentioned that have been advancing robotically the exploration of the planet at just a wonderful pace, supporting a vibrant community of senior, mid-level, junior student researchers who are trying to pull every ounce of information out of these data sets. So that's been great. What's not been so great, in my opinion, is the sort of idea of getting people there. Let's get humans to Mars has been, decades away for decades.
It's always 20 years, Jim. Always 20 years.
No, 30.
And
30.
And
30. Oh,
and
sorry.
NASA always their siren song is humans to Mars, moon to Mars, humans to Mars, and it's great that we're on the edge of getting people back to the moon, and we'll learn a lot from that. But it's certainly has been frustrating because a lot of what the robotic program is doing is paving the way for people to go there. Let's understand the environment that people and equipment that's with people and life support systems, all that are going to be dealing with. And that's partly what the robotics program is doing. And partly what the robotics program is doing from orbiters, landers, and rovers is figuring out where to go. Where should they go? Where they can access ice, for example, in the shallow subsurface, other resources to help live off the land as much as possible. So a lot of the robotic effort has been, in support of eventual human exploration, but it's been frustrating for me personally and many of my colleagues to not see the human program make the advances over the past 50 years that maybe we had hoped at the end of, say, Apollo 17 in 72. So,
boy, there's so much to unpack there, but we got to go to another break. So stand by. We'll be right back. And we're back. So, Jim, you brought up some really good points there. One thing I love to do, which is kind of masochistic, really, is look at polls over the years of NASA's popularity, and starting with some of the Gallups and others that were done in the 60s, and then continuing on through till yesterday. You're right. I mean, NASA has this incredible brand. It's got world recognition. It's like, I don't know, it's up there with Coke and Nike and a handful of others, Taylor Swift.
You see people walk around the world with NASA t-shirts. You don't see them with FDA t-shirts or IRS t-shirts. No,
That's
it's
right.
NASA, right?
And the taxpayers don't get any cost relief from those logos because nobody ever pays NASA for their use. But interestingly, though, from those earlier polls forward, the more specific the questions, the lower the support. So when you say, do you support NASA? Yeah, NASA's great, 70%. Do you support the United States being a leadership in space through NASA? You bet, 50%. Do you support going back to the moon with human beings in the 21st century? Crickets, 17%, And I remember these numbers very generally. So what I'm getting at here, what I'm steering towards is Mars sample return. For the first time in quite a while that I remember anyway, we have a real sudden left turn on a robotic Mars program, which went from, hey, this is great, we can do it, we've been talking about it 50 years, let's go, to, oh, golly, this is going to cost too much. Let's slam on the brakes and ask private industry to see what they can come up with, which was kind of the NASA administrator has done a couple of things in this term. Generally, I think he's been quite good, but he's done a couple of things that were sort of a head scratcher. This one was a what? And it was one of those, I think it was a Tarek, wasn't it? One of those Friday afternoon.
Oh yeah.
Let's kind of hide this behind the curtain press conferences. It's like, oh, well, this is really weird. So I've given you a lot of things to sort of unpack here, but what's your sense on MSR at this point?
Yeah, well, it's interesting because we are both closer to MSR than we've ever been, and just as far as we've ever been, right? And we're closer because we are collecting the samples. We actually know what most of them are. We still have a bunch to collect with Perseverance, but most of the sample cache has been completed. And we're going to continue over the next few years to collect an even better set of them. So, Perseverance and the Mars 2020 mission in Jezero Crater is part of Mars Sample Return. It's the first part. So we're actually doing it. That's exciting, right? The frustrating part is that getting them back is going to be the hardest robotic thing that NASA or any space agency or combination of space agencies have ever done. And maybe the hardest part is launching off of this surface robotically. That's something that's never been done. It's a difficult place to land on. It's a difficult place to launch from. So it's a really hard thing. So it's not surprising that it's going to cost a lot of money. It was unfortunate timing that, we're going through a big squeeze in federal spending right now. The economy not doing so well, so federal spending for non-discretionary, the things that we choose to fund, not that we have to fund. It's a tough time, and Congress makes all these decisions, and Congress is squeezing the budgets of all the agencies, including NASA, which makes it really hard to do expensive and difficult things. So the variable that you can control, if you can't get more money, you can stretch out more time, right? And so that's sort of the way it's worked out. I'll just share with you I guess it's not surprising to see NASA reach out to the commercial world for ideas and support. I mean, NASA is doing that with lunar exploration. Commercial lunar payload services and other programs are involving a lot of non-traditional companies. It's not just the big aerospace companies that NASA has relied on in the past, but a lot of smaller, nimble companies. And the jury's still out on how that program really is going to come down, but it's, you take a little bit more risk, but you have more opportunities. And that's exciting. And we here at ASU, we work with a number of those companies helping on the science side and, operations and that kind of stuff. So that's exciting. And so it's not surprising to see them reach out to similar kinds of companies and the big aerospace companies and ask, hey, have you got any ideas that can help us with this? But what was just disappointing to me personally was for NASA to go out in public and say, we can't do this. It's like, I don't want NASA saying that. I don't want NASA saying you can't do it. You're NASA. Come on.
Well, and where did this $11 billion number suddenly come from? Because
that was the high.
It was more like 7.
It was the high end of the range of studies. A number of studies came out. There were a number of them, and the administrator and others at the senior levels chose to focus on worst case, and so that takes you to the high end. And if you want to set expectations with Congress and the administration on worst possible case, you got to go to the high end. That's comparable to the cost of James Webb,
right?
Ultimately.
Yeah. Or in today's dollars, Viking, or any of the other big flagship
And so it just doesn't seem to be the case that the government can afford that right now. And so they're looking for ideas. Hopefully, commercial will help. But in the end, it's got to be NASA's going to solve this problem. I'm a ridiculous optimist. I think they will solve the problem. I think they'll come up with some ideas, maybe with some commercial input. But the centers are all working on their own studies as well as the commercial companies. And so it'll be a combination. Of course, those studies aren't due till next month sometime. We've got an election coming up. There's going to be a change of administration. There's going to be a change of Congress. Potentially likely a change of administrator, just going with how things have gone in the past with change of administration, right? So I wouldn't expect NASA to be able to make a real decision on this until spring, summer of next year. And by that time, we'll know more about what the Congress is like, what their appetite is for spending, what the administration is like, what their appetite is for space spending, what the economy is like. So all these things, this is something that I didn't realize as a young person early in my career, how much of what NASA does is tied to the economy and geopolitics.
And I think just for some perspective, the fiscal year 2024 budget for NASA was something on the order of like 24.8 billion, which sounds like a lot, but it was 2%. It was a 2% cut from 2023. And of course, there's talks about the budget for the next fiscal year. And in fact, I think the NASA Authorization Act just got cleared through the House. And when it comes to space science spending, the part that flagged our team, my colleague Brett Tingley, was that there is a little passage in there that directs that specifically says that the decadal survey primary targets now need to be like really weighed against budgetary realities, which is different, I think, as an approach to say, as a decadal survey for science, these things, Mars sample return, et cetera, Grace Roman, or the Roman Space Telescope. These are our priorities overall for science, rather than a priority for science. Maybe if we have the nickels and dimes to pay for it, that's not final. It has to go to the Senate, and we'll see. And it's just one small part of the whole thing. But it was a part that affected science that I thought, it's kind of that trend that you were talking about, Jim, about what are we going to pay for versus what are people, or what do we want to do for the science itself?
And look, that 20 plus billion, that is a lot of money, but it's less than 0.5% of the entire federal budget. And so I often, I give a lot of public talks, and often someone will rightly ask, why are we doing this? There are homeless people. We need to cure cancer. And it's like, yes, we need to do all those things. But the reality is, if you completely eliminate the NASA budget, zero it out, do any of those things, we're not going to cure cancer with that money. We're not going to solve homelessness and hunger with that money. Of course, we have to try to work towards those bigger societal issues. But in its own way, NASA is providing societal impact, right? It's STEM education, it's motivation, it's inspiration, it's national pride. There's all, and technology development, by the way.
Okay, Tarek.
And they are researching cancer too. There is that.
Tarek,
yes, of course.
We got to go to an ad. Sorry. Okay. Tarek gets carried away here. We'll be right back, and I want to ask you to talk a little more about the decadal survey. So stand by.
Sure.
So during the Apollo years, as we often talk about here, about 4.7% of the federal budget was going to NASA's expenditures, at least during their wartime years, which was 1964 through 66. Now it's about a tenth of that. And, you were talking about the NASA budget, but it's also important to point out that planetary and robotic science and, associated things like astronomy and so forth get, like, if that's the NASA fire hose, you guys get the soda straws worth. I mean, there's this dribble that comes out the other end for planetary science. And, but I was wondering if you could talk a little bit about what the decadal survey is, how that controls what we're doing, and how that does relate to budgets, because I don't think most people know that much about it.
Yeah, and sort of the bigger picture, NASA is funded as a federal agency by Congress, which takes in taxes and distributes accordingly. And members of Congress are not rocket scientists, generally. There's a few astronauts that have been in Congress and that kind of stuff, a few physicists here and there. But so they're not in a position, and they acknowledge they're not in a position to tell NASA what to work on. So they, for the past few decades, have been reaching out to the National Academies of Science and Engineering and saying, hey, National Academies, could you convene a panel of experts and tell us what should this agency be working on that's best for the country, that's best for science, that's best for the world, whatever. And so the National Academies then has conducted these surveys called decadal surveys, one for every decade, for each of the four major areas of NASA science. There's planetary science that I work in. There's astrophysics and astronomy, which many of my colleagues work in. There's earth science, and there's heliophysics, the study of the sun. And so for each of those areas, the National Academy convenes a panel of 50 to 100 experts to be like the main committee, and then they reach out to the communities of hundreds to thousands of researchers around the world and basically do a survey. What do you think is the most important thing? Send us your information, send us your ideas. And they get hundreds and hundreds of what they call white papers, 2, 3, 4 pages. Here's why we need to study the atmosphere of Neptune. Here's why we need to go back to Venus. Here's why we need basic fundamental research in meteorites, whatever, right? They get hundreds and hundreds of papers from around the world. And then this steering committee then has to kind of sort through it all. They have town hall meetings, and it takes several years. But eventually they come out with the document at the end that is as close to a consensus as they can on what the community believes NASA should be working on in the next 10 years. And so those are called decadal surveys. And then Congress looks at that and says, great. And then they turn to NASA and say, NASA, are you doing this? And NASA had better say, yeah, we're doing this, because that's what Congress asked, to be done. And so, so there's a direct alignment between what the community broadly thinks is most important to be working on and what ultimately gets funded. And I think that's great. I'd rather have it done that way, even though it's a clunky and slow process. And 8 years in might not really be the same set of priorities as 10 years ago when the survey started. But I'd much rather have it be done from the ground up that way than have a small number of bureaucrats high into government be telling everybody what should be done, or members of Congress who aren't rocket scientists.
Does that process, though, what we were talking about Perseverance earlier, and how it's cached these samples, hopes to collect more, but we still don't have that capability to bring it back. And sample return was like a high science capability. I'm curious how that kind of situation comes up then. Is that a matter of we made these decisions because we thought that the financing, the funding and the support on that directional level would be there, and then it changes? Or is it a technical hurdle as well? Or is it kind of all of that stuff?
Yeah. I mean, it's great question. It's driven by the science. Like bringing samples back will tell us so much about Mars and the history of Mars as a planet and how we will interact with Mars when we go there as people, just like the Apollo samples did. Apollo samples weren't acquired for science. It was to beat the commies, right? That's why they went to the moon. But those samples have revolutionized our understanding of the Earth-Moon system fundamentally. Huge impact on planetary science. Same thing will happen when we bring some of these rock and soil samples back from Mars. But the survey, so it has to be driven by the science, but there's a pragmatic side to it as well. Any idea that's posed as hey, we should do a mission to do this is studied and made sure that it's not going to cost $100 billion or some ridiculous number. It has to be pragmatically within that envelope of typical NASA funding, or what you could expect over the next 5 to 10 years might be typical NASA funding, taking into account inflation and projections about what the economy is going to be like. So there is a pragmatic logistical aspect to the decadals as well that we'll study, especially the big missions like MSR, Europa Clipper, others, but also medium and small missions. Can these reasonably be fit into the budget? And if the answer is yes, they'll survive the process. And then it becomes a policy issue at the highest levels of the administration, Congress, NASA administration. Among these choices, which have been ranked by the scientific community, which can we really fit in? Which one does the president like best, or whatever? I mean, just lots of other sort of programmatic and policy issues will then come into play.
So how can I phrase this? This is a big generalization, but as with MSR, so goes Viper. A little different. I mean, that seems to be at least trying to become an outright cancellation. I'm not sure it's there yet because I know there's still parties kind of grinding on it.
It's not dead yet.
But
Flesh
he's
wound.
dead, Jim. But we have the Viper, which is Mars Sample Return obviously is bringing back rocks from Mars that were collected by the Perseverance rover, which I thought was a very daring move, considering all that was designed long before they had an actual budget for Mars Sample Returns. That was pretty cool. And then Viper, which is a rover to land in the south polar regions of the moon and go sniff out so-called volatiles, which include water and other things, which is, at least as far as most of us who are non-scientists can see, a critical step in the path of getting humans back to the moon, essentially sustainably. If we just want to go do another Apollo 11, that's one thing. Oh, beat China. But in terms of doing it for the long term, you need to really sniff out what's there and understand it. So, Viper.
Yeah.
Tell us a story.
No, I mean, a lot of us in the planetary science world have been having a lot of what were they thinking moments about this. And, and now a lot of people in Congress are having the same thoughts. Congress wants more details, which haven't really been forthcoming on why NASA made that decision. The community is looking for more details. Why was that the necessary path? Were there other options that were explored and discarded for perfectly valid reasons that just haven't been discussed? So I think there's more information coming on that, but it would be fairly unprecedented to have a mission that far along where that much money has been spent. I mean, for goodness sakes, they're in thermal vacuum with the spacecraft.
Right.
To cancel it outright. So I don't, I'm not privy to what happens on the upper floors of NASA headquarters. Don't know all the details. Again, I'm an optimist, so I'm hoping that there's a logical story that'll come out. Might have to be dragged out by Congress, or that they will say, you know what, maybe we made a mistake. It's not so bad to say you make mistakes. Not so bad to make mistakes. It's a space program. It's a hard thing to do. And given that the community and Congress find this so important, we need to figure out another way to do it. And this is, of course, what's happening with MSR. It's the community and Congress. This is important to do. The decadal says do it, and so we're trying to find another way to do it. So my hope is that we'll get back onto that path. With Viper, nothing's been, as far as I know, nothing's been unscrewed and taken apart yet. So I think there's still time, but maybe not an optimal process for sure.
Can I, as a scientist, Jim, because I have a lot of questions and concerns in some of the decisions I've seen come out over the last 6 months, but I'm not in the science trenches watching it all unfurl, and I was a bit
thank
alarmed.
God for NASA that we were both excluded from that.
That's right. Well, I mean, Jim was talking about the math earlier, and I almost tipped my hat to your successful bout with differential equations, the bane to Rod and I.
Well, and that he liked it. He said he liked it.
I never said that.
Oh, okay. I thought you said it was fun.
So I've been very confused because over the last 6 months we have seen budget zero outs for things like Chandra X-ray Space Telescope. You see the Viper cancellation. You see a forced delay for the Escapade mission from October of the Escapade Mars mission. NASA sending 2 missions to Mars on Blue Origin's first New Glenn rocket because they're I guess not confident that rocket's going to be ready. So then they slip to the end of that window in spring of 2025, which feels like pushing it. And you've got this ripple of, if I'm a layperson, it just seems like they're choosing not to do the science, choosing not to do it. The Chandra one hurts in particular because it brings back memories of initial attempts to kind of close down Spirit and Opportunity when they were still working fine. They weren't stuck or anything. Right. And that attempt, which was an attempt just to save money for other projects and move them around at the expense of science. We saw that again with New Horizons, right, Rod? We talked about that on the show, where they were going to just do that. And it just seems to me that in the last 6 to 8 months, we have seen a trend that that could be really worrying on the financial side of things. And I'm wondering if that's if the people that are doing the science are concerned, or if it's just like an appearance issue, or maybe I'm just like a panicky person.
Yeah.
I mean, I'm not calm at all, Jim. So
You could say that again.
Chill out a little bit. All right. So yes, very concerned. And one of my hats with the Planetary Society, we express our concerns. We write, if you guys know Casey Dreyer, and what he writes about is very frank and honest, and we're very concerned. The community is very concerned about the future of science within NASA. And I think what you're seeing, I think it's actually personally quite simple, right? It's good people dealing with a very difficult problem, and that is a shrinking budget. Mm-hmm. And within that environment, you have to make priorities. And in some cases, priorities have been made through documents like the Decadal Survey. In other cases, there are programs and missions that weren't in the Decadal, that weren't imagined in the last Decadal, which is sort of, we're coming to the end of here. And so they don't know what the priority is, and there's not enough time because decisions have to be made because Congress says, give us your budget. And so decisions are made high up in the NASA administration and in a way that maybe not effectively communicated as it should be with stakeholders. I think it's good people with a difficult problem of a shrinking budget and somewhat uncertain priorities. One priority that is very clear, at least with the current leadership in NASA, is that Artemis is the top priority. Yeah. And Artemis is mostly not science, right? The money that goes into Artemis is rockets and hardware and life support and landers. It's a lot of technical. It's a difficult problem getting people to the moon, bringing them back, making them safe. And by the way, we want to try to do some science there, which is where Viper comes in. But it's just not science within Artemis doesn't have the priority that science within the science division of NASA has, right? And so I think there's where policy comes into play. There's where, if science were truly regarded as critical to the success of Artemis or the success of Moon to Mars, then the human program would play a bigger role in supporting the robotic support for the human program. But as Rod and I have talked about in the past, there's kind of this wall, this bureaucratic wall between the human part of NASA exploration and the science robotic part of NASA exploration. And so I think, decisions have to be made in a realm of a shrinking budget where priorities are not maximized for science. I think it's good people in a tough situation making those decisions.
If only we could get some of that black budget from Space Force to roll over to science, but that's a silly thought. You talked a little bit about the entry of commercial players into non-human space flight, which is, landers and rovers have often been built by by commercial contractors working for NASA. But now with fixed price and all that kind of thing, it's a whole different world. We've talked about that a lot. But, you were mentioning both MSR and possibly Viper going out to different bids in the commercial realm. And yet, in terms of commercial non-human space flight, so pulling SpaceX out of the equation, we haven't seen much success. So what kind of milestones do we have to pass before, and I'm asking this as a layperson, obviously, from the outside, the peanut gallery, when do I trust these guys to be able to do something like land on the moon, for instance?
Yeah, well, look, we haven't seen much complete success, right? But don't forget, how many times did it take NASA, with the full backing of the federal government, to hit the moon? Not to land on it, but just to hit the moon with the Ranger program. Was it Ranger 8, 9, right? That they even hit the moon, right? And so now you've got these smaller companies, many of them startups, working on shoestring budgets compared to what the government had when they were trying to solve these problems. And not only did the initial ones, they could hit the moon, but they almost landed right. And, the Japanese one kind of got it on its side, but they did a bunch of work science anyway. The IM one landed on its side, but okay, but it was a soft landing, right? And that's for a small company on a low budget and a high risk program, I think there's plenty of successes to point to. Have any of them reached full mission success yet? No. What does it take to meet full mission success? All of the mission assurance, all the redundancy, all that stuff that NASA does, hundreds of millions, billions of dollars it takes to do that. So NASA has accepted more risk because the cost is lower, more opportunities. So we've got a couple more of them coming up late this year, early next year, a few more attempts. We saw SpaceX didn't launch their first Falcon 9 successfully, right? I mean, it took them a while. Now it's like routine. We don't even notice them anymore, right? And so I think the more of these that the commercial world gets under their belts, the better they get at launch and landing and operations. I have confidence in the program, and I hope that the key stakeholders, the public, members of Congress, have the patience to realize this is hard. The risk is higher, but we've got a lot of opportunities here, and they're going to learn. In the meantime, that money is not being sent up in bags and blown up in space. Right? The money is being spent here on Earth in companies and universities and labs. It's people. Most of the money is people. Right. And it's smart people. It's people who push the limits of technology and the frontier of science and exploration. And it's happening, here in America. So I think those are all good aspects of this. So maybe I'm not as pessimistic as you, Rod.
So, that's the answer we were hoping to hear. And by the way, everybody, that was completely unprompted other than me asking the question. So this is straight from him, and we got to make sure to get that in social media. Okay, Tarek, go for your last one.
I was going to say, I think that Jim just said that every dollar spent on in space is spent on Earth right there, right? Is what he said.
Yes.
Yeah.
Yes.
So I just wanted to ask, because we've been talking a lot about the moon, but I know that Rocket Lab wants to go to Venus, and they're building their own Venus mission. And and Elon Musk, in SpaceX said that, in the next window in 2026, they're going to launch a Starship to Mars come hell or high water. And then if that goes well, they're going to launch people there. 2 years in. Of course, they're known for...
Because how hard can it be, right?
Well, they're known for like wildly ambitious timelines, but the concept of a commercial science mission, fully private, I find very compelling, because that's the sci-fi life that we were all sold by Arthur C. Clarke and the rest of them.
That's the heroic age, right?
Exactly. And I think I know where you stand on this from what you just said about all of these moon missions that we saw launch and achieve partial results, or some of them like Astrobotic going full bigger with the next one. But what is the risk reward look like for that more ambitious commercial science there? Is it the cachet of the private program, or is it an opportunity for different types of scientists like yourself, or with different even specialists, special different expertise, niches, I guess is the word, to answer a different question that maybe wouldn't get all the way up through the echelons of a decadal survey, but Peter Beck and his rocket, can get it there, can get the instrument there.
Look, it's really simple, right? Why do companies exist? They don't exist to do wonderful things for humanity and explore space. They exist to make money, right? That's why companies exist. And so what it all comes down to, in my mind, is there a business model that closes to do commercially focused science and exploration? And in order to prove that, you have to take some risks initially. You got to find some investors who might be more philanthropic than others, right? To get, to try to, like what Rocket Lab is trying to do, that's privately funded by visionary people and institutions who are trying to make the case that, look, we can do this. And look how it's going to pay off. We're going to learn new things about the Venus atmosphere or the surface of the moon, whatever, okay? But they have to sustain that they're going to have to show that they can close a business model. And so, for example, one of the things that we're working on here at ASU is working with the future providers of the lunar rover that will be for the Artemis astronauts, where NASA is procuring that as a service. It'd be like a rental car on the moon. When our astronauts are there, they get on the gold board and they got priority. And then when the astronauts aren't there, you can use this as a rover, a robotic rover, just like a Mars rover, and explore the moon. And we're going to pay for this, but we know we're not going to give you enough money to close your business model. So they need other payloads. They need other, institutions, organizations, space agencies who want to go to the moon to do science, but they're going to have to pay for it, right? The company's not going to do it for free. It's not going to get donated. There aren't a line of philanthropists and billionaires out there waiting to fund this out of pocket, sadly. But that would be great. But, so it just comes down to being able to close that business model, and every organization, NASA included, who could pay for some of this, has to make that case, that ROI case. Here's what we're going to gain from that. And to date, most of the funding for this kind of stuff has been by governments because there is no profit in it, right? What's the profit in knowing what the composition of these rocks behind me are in Jezero Crater? There's nothing a business can point to and say to their stakeholders, we made money off of that.
Someone would pay top dollar to have that rock, though, from Mars on their desk, to have
not enough to fly it home, my friend.
I'm just saying.
Will they pay?
Maybe.
Yeah, will they pay? Will they write the check up front?
Yeah.
Will they write the check 10 years in advance to do it all? It's hard to find those kind of folks. They're out there, but they're very difficult to find.
Well, and speaking of that, Elon, if you're listening, instead of burning $20 billion on Twitter next time, how about just taking over the space program? You can do it. Okay,
that's 40. I think it was 40 billion.
Well, that's what he spent, but I'm talking about how much he's actually ground up and probably lost, but I know that's a big estimate. Jim, before we wrap up here, I'd love to hear about any future books you have coming up, any big talks you might have coming up that people could see, your next efforts, and finally, if you could just touch on your work with the Milo Institute for a moment.
Yeah, so I've been giving talks, book talks. My latest book, The Art of the Cosmos, and then before that, Hubble Heritage, just some spectacular picture books, coffee table picture books with lots of great stories. John Grunsfeld, the Hubble repair astronaut, wrote a great foreword for the Hubble book. So I've been giving talks about those. I'm pitching a new book about sort of why do we have to get off this planet? And I claim we have to get off this planet. And I mean that slowly, metaphorically, as a species, but also, tomorrow and the next day. There are lots of ways that space in near Earth orbit and beyond affect us and affect our future. And so I'm pitching an idea for that.
And you have a good TED talk that people can see on that very
Exactly. Then and the book would be kind of based on that talk. So that's kind of what I'm up to. And of course, trying to work with the Planetary Society to make sure that our members of Congress and the public get what they want out of the space program and understand how it impacts kids and their teachers and jobs around the country and the national prestige that NASA enjoys as the leader of the world in space and all that. So that work is just going to continue.
Fabulous. Tarek.
Yes, Rod.
Where can we track what you're up to these days?
Well, you can find me at space.com, as always, on the Twitters, I guess the X now, at Tarek J. Malik. This weekend, you will find me glued to my computer as we watch Crew 9 launch not 4, but only 2 astronauts to the International Space Station so that they can leave some room for Butch and Sunny to come back to Earth back in February. And that is set for lunchtime Eastern time on Saturday with docking on Sunday. So it's the full weekend for that. So it's going to be really exciting. Oh, P.S. There's space rewards in Fortnite until October 1st. You should look for that.
I was waiting for something gaming.
You can get a space cake!
Because you are gamey. All right. And of course, you can always find me at pilebooks.com or at astromagazine.com, where I hang out. Please remember, you can always drop us a line at twis@twit.tv. That's TWIS@twit.tv. We welcome your comments, suggestions, and most of your thoughts. And I will answer your email. I always do. New episodes of this podcast published every Friday on your favorite podcatcher. So please make sure to subscribe, tell your friends, and give us 5 thumbs up. And if you don't do it for us, do it for Jim, because he's really good. He's a consummate space communicator. You can also head to our website at twit.tv/twists. Also, don't forget, you can get all this great programming ad-free and a lot more other cool stuff if you join Club Twit for just $7 a month. Can't bring back a rock from Mars for $7 a month, but you can join Club Twit and help us stay here to serve you better. And you can also follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook and twit.tv on Instagram. Thank you very much, Jim. Thank you so much for coming today. This has been a real treat.
It's been
I could have gone twice as long, but next time. So we'll have you back if you're willing.
Sounds good.
Okay. Thanks, everybody.